x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Got to make sure we remember that. It comes up a lot in this class. So that gives me negative 1 plus or minus the square root of negative 3 over 2. But I need to take care of that negative underneath the square root. That makes an I. So there is my last 2 solutions that I got via the quadratic formula. Does that feel okay there, Tom?
Yeah.
So, yeah, go ahead.
You know, on the first one, I like to say factor x squared plus x plus 1.
Right.
Is there one within this that you might do that?
That you could factor it more?
Yeah.
Yes. Yeah, I think the other 3 you would be able to factor them more. Absolutely. Does anyone have a preference on A, B, or D? Which one you'd like to see done? D? Annalise, is that okay? Okay. So we'll go ahead and do the same thing. So we'll set this up and we'll take our polynomial and we'll divide it by the factor that's given. I don't know. Okay, hold on. Being stupid. Thank you. Yeah, I was like, something's going on here. What's the problem? I don't know. I am El Stupido. There we go. All right. So what we get then is we have x minus 1 times x cubed plus 2x squared plus 9x plus 18. Everybody's okay with that? What we need to do now is check to see if we can factor this polynomial anymore. So the methods that we have available to us now, since we don't know any factors for this, we can't do another synthetic division on this, but maybe the factoring tree methods would still work on this. Right? This is a 4-term polynomial, so it stands to reason maybe I should try grouping. Everybody okay with that plan? So from the first group, I can take out an x squared. And from the second group, I can take out a 9. Notice here that the x plus 2 is in common to each of those. And then I still have the x minus 1 hanging around. Okay so far there, Tom? Well, we have to check to see if either of these guys can factor anymore. So x plus 2 obviously can't, right? Because it's a degree 1, so there's nothing more to do there. X squared plus 9, can that factor more? Be careful. So it might, at first glance, look like it's a difference of 2 squares, because you have something squared plus something squared. But it's not a difference, it's a sum, and there is no sum of 2 squares factoring. So this is gone as far as you can go. That would be our final answer for the factoring part. If we move down to part D then, we're just going to set each of those pieces equal to 0. So I get 1, negative 2. And to solve x squared plus 9, I'm just going to do that directly. So I'll subtract 9 from both sides, and then square root both sides to get plus or minus from the square root. And the square root of negative is going to give me an I, and the square root of 9 is 3. So these would be my 3 answers there for part D. Tom, do you feel okay there?
No.
Okay. Elena, is that good?
Yeah.
Didn't think to do grouping on it once you got to the 4-term piece?
Yeah, because that's why I was confused.
Mm-hmm. So I was careful to give you things that still you could do with the factoring tree when you're done with it. even if they weren't specifically quadratic like the previous three was. So any of those factoring tree methods still could be useful to us along the way here. So they don't go away, but they may not be the thing you want to start with. They may be something you use in the middle, if that makes any sense. Annalise, you had your hand up earlier. Was this what you needed to talk about? Okay. Do we feel a bit better about this process after going through a bit of the homework here? Okay. Just as one little aside, was everybody careful on part B doing their synthetic division, including the 0? Okay. I tried to pick one where you had to, show you some different things, right? Like, if you forgot the 0, you wouldn't have gotten the 0 remainder at the end and should have been scratching your head as to what went wrong. But that was something we had to be careful about there, right? Because there's no x squared term. That's what I'm talking about. Okay. All right. So let's move forward a little bit. We're not going to go too much further forward today, but this process gets rather lengthy because, we're going to build up to the most optimal way of doing this. But the next step that we're going to do is, and the next obvious question is, what if I'm not given this information? Right? So in each of these problems, we gave you a factor to help you get started and get past the unfactorable part, the part that we couldn't deal with using the factoring tree. And you were left with, after that, something that you could deal with using the factoring tree, right? So what happens if you're not given a factor to start with? You have to find one. How are we going to find it? In the beginning, for where we're going to start, you got to kind of guess. So how many guesses do we have? Infinitely many, right? Like it could be x plus 1, it could be x minus 1, it could be x plus 2, it could be x minus 2. We have no idea what those factors would be. You're just straight up guessing. Now we can do better than guessing, and that's going to be the rest of this, the rest of the week spent doing lessons. We're going to kind of give us some tools to make it from, okay, there being infinitely many guesses to specifically, like a finite number of guesses. And then can we do better than that? Like of this finite list that I have of guesses, can I specifically target the ones that should probably work? And that's kind of where we're going to be going over the next couple of days, is to take this guessing game down from infinitely many choices to finitely many, but possibly long, to, okay, from that finite list, these are the 3 I'd want to try. Okay, that feels pretty doable. Does everybody kind of get the idea, or the plan at least? Obviously, we have no idea how we're going to do this yet, but that's going to be what we're going to be working on over the next several days, is when I take away that starting point, how do you find that on your own? That's kind of where we're going. Okay? All right. So, we're going to start by giving a theorem. This is called the rational roots theorem. Which I abbreviate as RRT. When we say root here, what this means is the solutions to a polynomial set equal to 0. Okay. What the rational roots theorem says is, hi. Good. Thanks. Juan.
You want me to say that your mom's waiting for you?
Oh, yeah, this is from 20 minutes ago.
I don't know.
Oops.
Thank you.
Yeah, you're welcome. Here's your thingamajigger. I don't know if you need this or not, but I'm going to give it to you. Okay, so what this rational roots theorem says is for a polynomial that has integer coefficients, the possible rational solutions are positive or negative, the factors of the constant term divided by the factors of the leading coefficient. So let's look at an example where we apply this, okay? Maybe one real quick aside before we do our example. Notice here that what we're getting are possible solutions. Remember yesterday that solutions, though, are related to factors, right? So just to kind of remind you, right, we said yesterday that if I know the factors of a polynomial, I can get the solutions and vice versa, right? So the fact that this isn't talking about solutions is still applicable if we're trying to factor something. That's the same information, or gives us basically the same information. Okay? So we'll start by just showing you how the theorem works. And then we'll do a second example here in a moment where we actually use this theorem to try to do some factoring. Okay? Everybody good with that plan? All right. So I'm going to start by listing the constant term. What's the constant term in this case? -40, okay? And then the leading coefficient is the other thing I need. What's the leading coefficient in this case? It's just 1. Good. Okay. Now that I have these, I need to list the factors of 40. It doesn't matter the negative sign. So what are the factors of 40? Those are factors of 40 are anything that divides 40. So what's a number that divides 40? 40, okay. 1, okay. 10. 20, okay. 2, 4. I think there's 2 more. 5 and 8. Everybody agree with that? I think that's the complete list. Sound good? Okay. Then I'm going to list the factors of the leading coefficient. What are the factors of 1? Just okay. Now I have everything I need. So my possible rational solutions are plus or minus 40 over 1, plus or minus 1 over 1, plus or minus 10 over 1, plus or minus 20 over 1, plus or minus 2 over 1, plus or minus 4 over 1, plus or minus 5 over 1, plus or minus 8 over 1. Now, do the over 1s really matter here? No, right? Anything over 1 is just itself. So how many possible solutions do I have here? Well, I have 2, 4, 6, 8, 10, 12, 14, 16 possible solutions, which is not great. 16 is kind of a lot, but it's a heck of a lot better than infinitely many, right? So at least now I'm like, okay, I got to check this thing. So let's check some of these and try to see if we can find a factor to get this problem started. So somebody pick one of the possible solutions from this list. 3 over 1. Why 3? There's not even a 3 on the list.
40.
You really want to start with 40?
Yeah.
I would typically, so if I look at the constant term, that constant term is not real big, right? Everybody see that?
Yes.
Relative to the numbers that are on our list, that's not a very big one. I typically wouldn't start with the biggest one or the smallest one. I'd pick some of the things in the middle. Yeah, so it doesn't really matter. So let's go ahead. I think somebody had said, what, here, 20? Sure, let's go for it. Okay, so I'll do 20. Ooh. And already I can see that this is not going to work, right? It doesn't matter what's going to happen next. I ain't going to get a remainder of 1 or remainder 0. You guys agree with this?
Yeah.
Yeah. So 20's out. Okay, let's try another one. 4. Okay. Didn't get a remainder 1. 4's out. Let's try another guess. 8. Okay. Why are we only picking positives, guys? Right? What do we know about one of the factors because it's a minus 40? Yeah, one of them has to be negative. But we can do 8 still. That's fine. You see why we wanted to get good at synthetic division, though, right?
Yeah.
Because, boy, it makes life a lot easier if you're able to do this quickly. That didn't work. -2, okay.
Oh my gosh, no, I just did that.
Okay. So we know that this is going to factor to x plus 2 times x squared minus x minus 20. So this part gave me the x plus 2, and this part gave me the x squared minus x minus 20. Can we factor this any more? Sure we can. X squared minus x minus 20 factors. How does it factor? X minus 5 and x plus 4, right? So yes.
Okay, if you're asking us to solve this, we have to accept that even the x plus 2 is 0 as well. So
Right, and now if we want to solve this, now that it's in factored form, we can take each of these, set them equal to 0, and solve. Of course. Is everybody okay with that? Now, what's the drawback to this? We're still potentially having to do a lot of synthetic divisions before we find something that works, right? Can we do any better than, okay, we have this list of possible rational solutions I'm just randomly picking from. Can we do any better than that? Is there a tool that we could have used to help us go directly to the ones that we think will work? How can we use the calculator? The calculator is going to be our tool. Let me give you a hint. We're going to go back to this from yesterday. So which one of these 4 things can the calculator generate for us rather easily? The graph. The calculator can give me the graph really easily, right? And then what am I looking for on the graph?
The vertex.
No. I'm looking for the x-intercepts.
Oh.
Because whatever the x-intercepts are going to be the same thing as my solutions, which will in turn give me my factors. So let's go back to this original problem that we just looked at, and let's graph this polynomial and see what we see. Okay. So if you want to follow along, I invite you to do so. If you don't want to and you just want to sit and watch, that's perfectly fine too. But I'm going to go ahead and I'm going to graph this polynomial on my calculator and then choose an appropriate window and look for x-intercepts. So what button do I press to look at the graph? Or what button did I press to get to here? The y equals button. Very good. Of course. Okay, and then I just typed in the equation exactly like it was given to me. Everybody's okay there. Okay. Now I'm going to pick a window. So the part of the window that I care about is going to be the x-min and the x-max. What's an appropriate value to pick for an x-min? Well, what's the smallest possible x-intercept I could have here? Negative 40, right? What's the biggest possible x-intercept I could have? Positive 40. So I'm going to pick something maybe a little bit smaller than the smallest and a little bit bigger than the biggest. Okay with that? I don't want to miss any possible x-intercepts. If I have to decrease my window and look at something smaller, I can always do that later, but I don't want to start small because it's very possible you end up with missing things on the outsides. So I'm going to start as wide as I possibly can, and then maybe have to shrink it in. Okay. The y min and y max don't really matter. You just need to make sure the y min is negative and the y max is positive, because we have to be able to see the x-axis, right? If both of them were negative or both positive, you wouldn't be able to see the x-axis, and then you can't find the x-intercepts. Okay, so I'm going to hit graph now. Okay, so there's my graph. I see 3 x-intercepts happened, but I can't really read where they're at because I'm zoomed way too far out. So I'm going to go back in and change my viewing window. So if this is negative 45, what do you think a decent end here would be? What, like
20.
Well, 20 is going to be like over here. Let's get smaller than that. Like I would say 5 or negative 5 or negative 10, somewhere in kind of that range.
7.
And how about over on this side? Yeah, something like that, right? So let's say maybe go negative 10 to positive 10 and see how that goes.
So you put that into the minimum.
Exactly, because
Your window thing.
how do I get to the window? It's the button right next to y equals.
Oh.
That says window on it.
Like, did you put an x3 plus x2?
I put in this.
How do you put in an x3? You just do it the x here, right?
Yep. Yep, exactly right. Mhm. Okay, so here's my new picture. Now it's much more readable, right? So if I look here, this is 0. That tick is negative 1. So it looks like we're crossing at negative 2. Agreed? And then here's negative 3. And then we cross again at negative 4. Everybody agree with that? And then if I go on the positive side, I have 1, 2, 3, 4. And looks like it crosses again at 5. So the ones in particular that I would be interested in would be negative 2, negative 4, and then positive 5. Any of those would be good choices to start with, rather than what we did was guessing randomly. Everybody okay with that idea? So the calculator is going to be a really helpful tool for me, because what this basically did is it took the guessing game out of the picture. I should be able to look at my calculator and have exactly at least one spot to start my synthetic division at, right? Is everybody okay with that idea? Should we do it again?
Yes.
Okay. Yes, sir. Of course. Uh-huh. Okay. All right. So the first thing we do is we're going to use the rational roots theorem to make our list of possible rational solutions. What do you notice here about this problem in the previous one? It's going to be the same list of possible rational solutions, right? How do I know that? The constant term and leading coefficient are still the same numbers, right? Is everybody okay with that? So I'm just going to go ahead and write that list down. But I'm going to write it in order. Not that it was wrong, the list that you guys came up with, but it was hard for me to find the numbers when I went back to try to highlight the ones that we're interested in. Everybody good here? Okay. Let's fire up the calculator and take a look at the picture. So again, I just typed in exactly the polynomial that we're trying to factor into the y equals menu. Okay, so let's set a window now. What should I use as my x min? What should I pick as, what should I set my x minimum as? It should be smaller than the smallest thing on my possible rational zeros list, or solutions list. So needs to be smaller than negative 40, right? So I'm going to do negative 45 or something, that's fine. What should my x max be? Has to be bigger than the biggest value on that possible rational solutions list. So let's do 45, yeah. Sound good? Same thing that we did last time, right? Not surprising since we have the same list of possible rational zeros. Okay, so I see two x-intercepts, right? The graph crossed two places. Everybody agree with that? But I can't read for the life of me where they were. We need to zoom in some. So what number do you want to zoom into on the negative side? Okay, it looks like it's maybe at -1. I'd probably do something a little smaller than that. Yeah, -5 seems perfectly reasonable. How about on the positive side? 5, okay. So we'll do -5 to +5. These are guesses. If I can't see it, I can always go back and shift one way or the other. But that should probably cover it. Okay. So I see one crossing here, and I just barely see the other crossing there. So my two that I'm interested in would be this one, which would be at what value? Okay, so it looks like this is 0. There's a tick mark there for -1. And then this spot should probably be then -2. Everybody agree with that? And on the positive side, so here's 1, 2, 3, 4, looks like 5. So the graph we're looking at -2 and +5 are the two that we're interested in. Everybody okay with that plan? All right, does it matter which one I choose? No, it's fine. Either one is fine. Let's just do -2. So we'll set up our synthetic division. Everybody good there? Now I have an option now that I didn't have previously. In the previous problems, I'd stop at this point and then try to factor this remaining piece. What else could I do here if I didn't want to do that? I have another thing I could divide with, right? We could do that instead. You want to do that instead? Might be easier than doing the factoring by grouping. If the factoring by grouping even works, which it's not guaranteed to. Everybody okay there? All right, so let's write down what we have so far. From the -2, we have the factor x plus 2. From the +5, we have the factor x minus 5. From this stuff, we have the factor x squared plus 4. Everybody's okay there? Okay. Can I factor x squared plus 4 anymore? What do you guys think? No, why not? Good, it's not a difference of two squares, it's a sum of two squares, so there's no factoring to do on that. So if I was being asked to solve, I'm done. This thing is factored completely. That's not so bad, right? When you know what to choose, the factoring goes pretty well, right? If I instead wanted to solve, what would I have to do there? Yeah, I set each of these equal to 0. So my solved answer would be -2, +5, and then plus or minus 2i. Okay with that? Now, I gave you guys, or I mentioned in passing last semester, an important theorem that can be really helpful for us in these solving problems. It's called the fundamental theorem of algebra. Well, it's actually the corollary to that. The fundamental theorem of algebra actually just says that, is that really all the time we had? That's okay. We'll pick up next time where we left off. I have nothing for you guys to work on.
I know. Hurry up. Okay, so she's not. Okay, so I have her. Oh, you want to? No, she's not like that.